After creating the geometry of the entire model, we can go ahead to the next tab, that is the Properties tab. In the Properties tab, the very first tool is for the material properties. So we can click over here and then click on Add, and here we can provide the information of the material definition, like the type of design. You can have steel, concrete, steel reinforced concrete, or user-defined material property. This is an RCC workshop, so I will be going for the concrete type of design. And the standard you can select from here. I'll select ASTM-RC. Database. From the database, I'll select C4000. Here, as you can see, the modulus of elasticity, Poisson's ratio, thermal coefficient, weight density, mass density, everything from the software, from the codes have been provided by the software. You can make changes to these parameters as well by changing the standard to none. However, I'll keep it as per the code. And I'll click on OK. We can have more than one number of material properties, depends on how we assign it to the entire structure. Now the next thing I'll do is go to the Section tab and define my section properties. By clicking on Add, I can define the section properties by numerous ways. So the first tab is about the database and user. Database, as in I can select the shape, I can select the code, and from the code I can select the section. That is about database. User defined, as in I can select the shape, check on this user, and as per this reference image, I can provide my own dimensions. Then we have the value type, in which we can have irregular section shape by importing from AutoCAD file. That's under the general section. Then we have SRC, that is steel reinforced concrete. So I can select out of all these options available and provide either from the database or user defined dimensions. Then combined, so these are the available shapes for combined sections, mostly for steel. Then tapered, so there are many ways in which I can have tapered sections by using shapes, general sections, from the database, user defined, from AutoCAD imports. Then lastly, I have got composite, wherein you can have steel girders and concrete deck. Okay, so this was about different ways in which we can define the section properties. In this workshop, we'll be using database or user tab, this tab, and I'm going to create 2 column properties and 3 beam properties. So I'll go for solid rectangular shape and provide column 1. I'll click over here for user defined, and I'll provide the height as 0.8. I'll have it a square column, so breadth will also be 0.8. Then further, I'll click on apply. After clicking on apply, I can go ahead and create the next section property, that is column 2, with different height and breadth. So that will be 0.6 by 0.6. I'll click on apply. For the next section definition, that is for the beam 1. Beam 1, I'll have the height as 0.6 and the width as 0.4. I'll click on apply, and beam 2 will have height 0.6 and breadth 0.3. I'll click on apply, and lastly I'll have intermediate beam with height, let's say 0.4 and breadth is 0.25. I'll click on OK to close this dialog box. Note that these section properties are nowhere connected to the material, or here we have also not defined any reinforcement to our sections. These sections are completely independent. So if you want to know how any reinforcements can be incorporated, then you have to go to the Design tab that is available in MIDAS Gen. Here we can provide the reinforcement, and the checking will be done by the software. Next is the thickness. So in the thickness, I'll add 1 for lower walls, let's say 0.45, apply, and for the upper walls I'll reduce it to 0.35. OK, and close. I'll close this particular command from here, and I get to my workstream menu. Do not use this close, otherwise this tree menu will get closed. So workstream menu. Now here the first property that I have defined has been already assigned to the model. This is by default. So my grade C4000 has been already assigned. If I want to select, then I have to double click. To deselect, I can simply click on this work plane and press escape from the keyboard so that anything that I have selected will get unselected. Okay, so similarly, the section property first has been assigned to the entire structure. So I need to make changes here. I need to assign separate sections for separate members. So I'll start with column 2. Column 2 for the upper stories. Now to note the story names, I can go over here to display story numbers. I'll go to the front view to select my columns. Now we know that after selection, this is a general selection tool, so whatever we select, all the members will get selected. I mean, when we create a box and then select the elements, then all the members are selected. However, we just want to select the column members. The column members are lying in the vertical direction, that is in the Z direction. So here in MIDAS Gen we have got a good tool, that is a very good tool, that is to select using direction filters. So that we can go over here, selection filter by direction, and choose Z axis. And then if I go ahead and select by using my selection tool, then you can see that only the vertical members have got selected. Okay, so after the 11th floor, I'm going to have my column 2. So to assign any of the properties to our section, all I have to do is select the elements and drag and drop the property anywhere on the screen. So as you can see that the section property has changed after the 11th floor. You can check it by double clicking on the properties. Now I will apply the beams. So I'll apply the beam 1 property to the lower floors. Now if I select here, then only these head members will get selected, but I want the beams, so these are going to lie in the XY plane. So I'll change the selection filter by direction to XY, and I'll select entirely. Then I'll drag and drop the beam 1. I'll select the upper floors, beams, and drag and drop the beam 2. Then for the intermediate beams, I can go on the top view and I can select all my intermediate beams for every floor, because all the floors are activated below this particular floor that we can see, that is the top floor. And then all I have to do is drag and drop. In this way, all my section properties have got assigned. Next is the thickness. So I'll go to the front view again. This time I want to apply only to the walls. The walls will get selected anyway, even if we select the entire, even if we select all the line elements, the property will be assigned only to the walls. So I'll change this selection filter back to none, and then I will select some stories. Let's say I'm having walls for these stories only. That is 0.45, and the rest of the stories are going to have 0.35. So I'll select the rest of the walls and drag and drop 0.35. So in this way, I have assigned separate section properties and thicknesses to my entire model. There is another way in which we can identify if we have applied or we have assigned the correct section properties, that is by color. So you can go to the display option, go to the draw tab, section, say random color, and click on apply. So we have got different colors for different sections and thicknesses. Also, to see the thickness of the walls, you have to go to the hidden option and check on the frame thickness and plan thickness, and then click on apply and OK. This is a default setting, so the next time you do not have to do it again. So here we go, our structure is created with assigning all the properties. So now to consider the stiffness of the member immediately prior to the failure, that means to consider the cracking of the members, as per ACI 318.14 clause 6.6.3.1, we have to provide 0.7 scale factor to our gross moment of inertia in the minor and the major axis. For the walls, for cracked 0.35, and for beams it is 0.35, the gross moment of inertia. So we are going to do that over here in this model. We'll go to the scale factor. This is the tool for changing the stiffness of the section. So we are going to provide scale factor to the moment of inertia for each section property that we have defined. So for that, we'll go to scale factors, section stiffness scale factor. Here I'll select column 1. Now I can provide, as written in the code, 0.7 in the major axis, that is Y, 0.7, and in the minor axis, which is Z, 0.7. I'll click on add replace, and similarly I'll do it for the column 2, add replace. Now for beams, I can provide, it is useful only for the major axis, so minor axis will be 1 and major axis is, as per the code, 0.35. I'll click on add. Similarly for beam 2 and for intermediate beam. We can see the changed stiffness by clicking over here and clicking over here, show stiffness, for the new column section property. This will be used for the further analysis. I have to also provide the wall stiffness scale factor. So scale factor wall stiffness scale factor, and here for elastic analysis this we have to provide the wall type as plate, and for inelastic it is CRB. So we'll provide over here because we have member type of wall element, this will be applied to the axial only. So even though we have option for bending and axial, so this is going to be 0.35. Now I have to select the walls. To select the walls I can go for the work tree, but I'm using over here the command as well in the work tree. So MIDAS Gen has got option to open the second work tree. Anywhere on this toolbar you can right click and check on this tree menu too. So an identical tree menu will be opened up on the right side. You go to the works tree. Now for easy selection of all the walls, works tree is going to be very useful. All you have to do is double click on the wall elements. I'm not double clicking on the thickness, I'm directly double clicking on wall element so that all the walls will get selected. After I select the walls, then I click on apply. So after providing the scale factor for the cracked members, I'll go ahead now to explain with all the available features in the Properties tab in MIDAS Gen. When it comes to column shortening effect, we have to consider the time-dependent material properties. MIDAS Gen has got options to select from various codes. These are all the available codes, as well as you can have time-dependent material properties user-defined. Because this is very important, because we are going to have lab tests on the material property. Whichever material that we select, we need to always go ahead for a lab testing, and then these lab tests parameters are provided right over here under the user defined. This is for creep shrinkage as well as for the compressive strength. Further, we have got nonlinear properties in plastic material under the plastic material. Other than that, inelastic hinges can also be applied.